Okay, yesterday we looked at half reactions. Let's do one review of half reactions for people that weren't here, and then we will get into some new material. So let's say that I have this reaction. Cu solid, copper, adding it to some silver nitrate, AgNO3. And I really don't need brackets around that, but I can stick them there. This is aqueous. This is a what type of reaction? Quick review here. Single replacement, very good. The copper is going to come in here and tap silver on the shoulder. We're going to go to table in our reference table.
Is this on our lab?
Is it on the lab?
Yeah, I think it's on the lab that we just did.
Close. That was NaCl and silver nitrate.
Oh.
It is, we're going to check table J on your reference table. And you should notice on table J that copper is just above silver.
Oh,
Someone check. Someone check. Yeah, it's just above. So, what are we going to kick out?
silver.
Yeah, we're going to kick out our silver. So, silver gets kicked out right here. And we're going to replace this with copper. And let's say that this is copper plus 2 ion.
Plus 2.
Yep, copper plus 2. Cu, parentheses, NO3. Good. Okay, that would be our reaction. Very good. You're thinking balancing, so we got to stick a 2 in front of that Ag and we look balanced. Now, we need to assign oxidation numbers. Underneath the bottoms of each one, we're going to put our oxidation numbers, and then we can do our hookups with Leo, Gur. So, what is copper?
Plus 2.
No.
0.
Oh yeah, 0.
Thank you.
The next
Ag.
Plus 0.
No.
I don't know.
Charge of Ag, which will be the same as the oxidation number, plus 1. Now, here's what I recommend. To do nitrate,
Yeah.
think about nitrate as the polyatomic NO3 negative. Okay, so don't think about the silver right now. Just think about the NO3 negative. We know oxygen is what? Negative 2, which will give a total charge of negative 6. To make this add to negative 1, nitrogen must be plus 5. Very good. Stick that right there. Over here, what's our silver? 0. Over to this side. We've got copper, which has a charge of plus 2. What's its charge?
Plus 2.
Which is the same as its oxidation number. Good job. Oxygen is negative 2. We've got 6 of them, so we're going to deal here with negative 6. And nitrogen must be what again? Plus 5.
Why can't I do math today? So what do you do with that?
Nothing. Good question. This 2 that is outside of the parentheses does not come
Wait a
into
minute.
play with the oxidation number. Okay? Now, here is where it does come into play, Sophia, just to kind of clarify this up. When you look at this, if you were to add these individually up, you'll notice that you get plus 5, negative 1, which would give you, or plus 5, negative 6, which will give you negative 1. Well, that doesn't balance out with that plus 2 until you take into account that you have 2 negative 1s. Okay, so that, it does come into play in the total charge aspect, but not in terms of writing the oxidation number. The other way you can think about this is copper is plus 2. Well, as a group, the NO3 is negative 1, and there's 2 of them coming from that 2. That's how you get the balancing out of the total charge. Okay? All right, now we're ready to do our hookups. We want to use our Leo RA up, Gur OA down. I'm going to the back. Do one hookup for us, Krista. Give us our Leo. The 2Ag goes from Ag plus 1 down to 0. I agree that it drops, but if it drops, is it Leo or Ger? Very good. So we can do that one first. That's fine. So Ger, OA, down, and what is our letter? Left. Very good. Then we've got the next one. Who can do the next hookup? CU. Very good. So CU is going to come all the way over right there, and we're going to label that as Leo, RA, up and right. Leo, RA, up and right. And we're now ready to write our oxidation and our reduction half reaction. So let's start here with our oxidation, and then we'll start over here with our reduction. To do our oxidation, we pick the loss of electrons as oxidation half reaction, which is the Leo. And what we want to do is write what they give us. What do we start with? Very good. Where do the electrons go? On the right, because of good old R. So I can draw my arrow and write what I link to. What do I link the Cu to? No. Okay, very good, but I only care about the Cu plus 2. And now I need to do my electrons. How many electrons are given off to go from copper 0 to copper plus 2? 2. Claudia got it. So I stick my 2 electrons right there. And that is the oxidation half reaction. Now I need to do my reduction. So what do I start with? Very good. 2. Ag, and I have to be very careful here, I must put the oxidation number that it has. A lot of people make a mistake and they simply write 2Ag and they don't put the plus 1. We're reducing this, which means it has an electron that's going to be added to it, so we got to make sure we have the right charge to start with. Where do the electrons go? Very good. They go on the left. I'm just going to put a blank for them. And then I draw my second arrow. Notice that my Ag plus 1 goes over here, and it's hooked up with what? 2Ag, 0. Now, I heard the muttering of Zoe saying, do we have to balance the stupid thing? And the answer is yes. And thankfully, if we kept the 2 there, it already is balanced, so we're good in terms of the balancing of mass. Now we have to balance out the charge. So how many electrons do I need to make 2 Ags that are plus 1 drop the 2 Ags that are 0? 2. The reason why is that each Ag requires 1 electron, but you've got 2 of them. So each Ag plus 1 would require 1, but because you have 2, you got to drop it down to 2 electrons. Now we have to do a check, and you'll notice that the electrons lost equal the electrons gained. That's good because that has to be that way for a redox. And now if we add them together, what should we get? Back to the original, except you will notice we did not include the NO3. Those are called spectators, spectator ions, and they're not part of the oxidation reduction reaction, so they won't be added up and they won't be produced again when we add these 2 up. If we bring over this, we get 2Ag plus 2 electrons, yielding 2Ag, and if we add those together, you'll see that we can cancel out our electrons right there, and we're going to get 2Ag plus copper yields copper plus 2 plus 2Ag. And this equation is identical to the one above, except for the ions that are not involved in the redox numbers not changing. So, example, the N did not change at all, the O did not change the oxidation number, but this equation then is identical. And that is called writing half reactions. Cassie, did you get that?
Yeah.
What's that? Any questions? 'Cause I know you missed the part from yesterday. Same for you, Jess. Questions from anything you missed yesterday? Okay, take out your reference table because now we're going to revisit a look at table J. And we really just did this, but one thing you want to be familiar with is that table J is used For single replacement reactions, table J is used for single replacement reactions. And the thing that's important to keep in mind is that single replacement are always redox. So single replacement reactions are always redox reactions. Okay, so those are always going to be redox. Now, if you notice your table J, there's a couple things here that we have to keep in mind with it. At the top, you've got your metal column. That starts with Li, and it goes all the way down here to gold, Au. And then you've got your non-metal column in table J of your reference table, and it starts with, what, F2, and it goes down to I2. What happens here is that in terms of redox, you have a very different thing occurring with the metals and the non-metals. Here's what I mean by that. At the top of your metal column, you have what are called your strongest reducing agents. Now remember, the strongest reducing agents, do they get oxidized or reduced? Oxidized. Very good, Mitch. According to our Leo, Ra, that the reducing agent is what gets oxidized. All right, so your strongest reducing agents are things like lithium at the top of table J. They are the most easily oxidized. But over here on the nonmetal side, it changes gears a little bit. These are, for your nonmetals, your strongest oxidizing agents. And what that means is they are easily reduced. Over here for your top of your metals, these guys are easily oxidized. So when we talk about the reactivity of a metal, the one that is toward the top is more reactive because it is a stronger reducing agent. What that means is it will give up its electrons more readily to a nonmetal, which acts as an oxidizing agent. And that's exactly right. The ones toward the top of the nonmetals will accept them very readily. And that's why when you take something toward the top of table J for the metals, it'll react very well with something toward the top of the nonmetal side. So something like Na and Cl react really well to form a stable compound because of the reactivities. Okay, let's try one more hookup here. But this time let's do it for a nonmetal kicking out another nonmetal. So let's say that we have F2 as a gas, and it's butting in here on NaCl. Remember, which atom does the F2 tap on the shoulder? The Cl. We coined it a Sadie Hawkins dance. It's going to come over here and tap Cl. And yes, F2 is higher up than Cl. So what will it kick out? Yeah, Cl2. And it will form, we've got Na plus, we've got F minus, crisscross to get just NaF, just like that. Okay, so solid, we've got gas and solid. Now, let's go ahead and assign oxidation numbers. F2 stands alone, 0, Na, plus 1, Cl, negative 1. Chlorine stands alone, 0, Na, plus 1, F, negative 1. Okay, Cassie, what is our Leo hookup? So I'm looking for, Leo says Leo Ra up. Which number goes up? It would be the, nope, Na stays plus 1 and plus 1. Cl goes from -1 to 0. Right there is our Leo Ra up right, and I need to label them. What number goes down? F. F goes down, so we're going to label our F as our GR OA down right. We're always looking for the number that goes up.
Shouldn't that be left? Yeah, it's left.
Oh, thanks. My mistake. Okay, once we have that written, now we can write our half reactions. So, oxidation. Someone give me my oxidation half reaction. Cl, and it's Cl -1, yields Cl2 plus a given number of electrons. This would be 2 electrons, and we need a 2 to balance the Cl's.
Is it ever going to be 1?
Mm-hmm.
Okay.
And our GR reduction, we would have F2 plus 2 electrons, yielding 2 F negative. Homework today is on writing half reactions. Have a good one.
Taylor,